Hi, my name is Carl Joshua M. Davantes, and this is the group chapter 12, and our topic will be prototyping. The overviews are prototyping, conceptual design, concrete design, using scenarios, generating prototypes, and construction. Okay, next. What is a prototype? Today we're gonna tackle about what is a prototype, why prototype, different kinds of prototyping, low fidelity and high fidelity, compromises in prototyping, vertical and horizontal, and finally, final product that needs to be engineered. Next. Hello. Okay, what is prototype? Prototype is an early model of a product built to test a concept or process. Kumbaga early or test model pa lang siya, and ang purpose niya po is bago po siya i-release sa public market, chine-check muna kung ano po yung pwedeng improve or ano yung magiging problema ng isang product. Kaya dumadaan muna siya sa pagiging prototype. One manifestation of a design that allows stakeholders to interact with it. Ang purpose din po ng prototyping is para ipakita sa mga stakeholders kung saan nila i-invest ang kanilang pera. Kasi walang mag-i-invest sa'yo kung di naman nila alam kung ano yung in-invest nila na product, kung di nila visualize or wala silang idea kung ano yung product na yun. In other design fields, a prototype is a small-scale model. Example of these are a miniature car or a miniature building or town. Next. Yan, example, 3D printing, a cheap way to prototype something. Next. What is the prototype in interaction design? In interaction design, a prototype can be among other things like a series of screen sketches, a simple and easy way shot to represent a product. And next is a storyboard, for example, a cartoon-like series of scenes para mag-visualize ang magiging itsura niya. Next is a PowerPoint slideshow. I-present yung design in a more clear way kasi PowerPoint siya. Next is a video simulating the use of a system. Para po siyang tutorial kung paano gamitin yung design interaction. Next is a lump of wood, for instance, the Palm Pilot. Para po siyang sa 3D printing pero with the use of other methods or materials. Next is a cardboard mock-up. A cheap way of presenting something kasi cardboard lang naman tsaka madali. Next is a piece of software with limited functionality written in the target language or in another language. An early model siya, the final parang pahapyaw lang sa isang interaction design. Kung ano ang magiging itsura with functionality. Kumbaga early model pa lang, hindi pa siya yung final product. Okay, next. Why prototype? Evaluation and feedback are central to interaction design. Kukuha ka ng mga feedbacks kung anong pwedeng improve sa product. Yun. Sa mga co-workers mo, investors, kuha ka ng feedbacks. Next is stakeholders can see, hold, and interact with the prototype more easily than a document or drawing. Para magkaroon sila ng idea or mag-visualize nila kung ano pa ang pwedeng baguhin sa isang product. Yun. Kasi mas better kung kunyari kotse. Tapos yun, nagawa ka ng miniature model ng kotse na maliit. Yung pwede nila pag-interact para ma-visualize nila kung ano yung magiging itsura niya. Next is team members can communicate effectively. Para yun nga, nagkaka-idea yung mga designers for some alternative designs. Ideas can be tested out. Yun. Prototyping encourages reflection, an important aspect of a design. Kumbaga is the way of prototyping something. Prototypes answer question and support design in choosing between alternatives. Yun nga, nagkaka-idea yung mga designer for some alternative designs para kung may kung may ibang feedbacks man yung ibang investors, para magkaroon din sila ng ibang alternative design, hindi yung isa lang, para may pagpipilian din sila. Next, low fidelity prototyping uses a medium which is unlike the final medium, for example paper or cardboard. Kumbaga easy way siya of prototyping something kasi gamit mo lang naman is paper, cardboard, wood, sketches, etc. Cheap siya and easy way of prototyping or representing something of a product like car, miniature, town, ganun. Next is quick, cheap, and easy to change kasi mga wood, cardboard lang naman gamit. Examples, sketches of screen, task sequence, and so on. Post-it notes, yes, storyboards, and Wizard of Oz. Yun. Next, yun, storyboards. It is a series of sketch showing how a user might progress through a task using the product. Often used with scenarios bringing in more detail and chance to roleplay. Para siyang tutorial kung paano mo gamitin ng isang product. Example lang, paano mag-interact sa isang website or yung possible problems na may encounter ng isang user. Next, yung example niya, storyboard. Common way of representing something is also easy and cheap. Next, sketching. Low fidelity prototyping often relies on sketching. Don't be inhibited about drawing ability practice simple symbols. Common way of prototyping because it's cheap and madali compare sa iba. Next, okay, tapos na guys. Susunod naman sa akin is Shiela Caasi. Good luck, kaya mo yan, kakabahan. Peace.
Hi everyone, I'm Shiela Caasi from ISS 11 and this is my report. First is prototyping with index card. First, we need a index card with a size of 3 by 5 inches. Next, each card represents one element of interaction. As you see at the left side, the figure shows a different element of interactions. Next, in evaluation, can step through the cards. In every cards, dapat is yung mga nakalagay is yung mga questions na kailangan, yung mga important details na dapat sagutan ni users. And dapat is yung kaya lang sagutan ni users. So next is Wizard of Oz prototyping. Prototypes for the Wizard of Oz allow you to test features that have yet to be developed. Only a simulation of the actual functionality is tested by the user. The Wizard of Oz puts the screen in the background instead of providing genuine functioning. The method's goal is to save time and money by identifying which functions are needed initially. The user thinks they are interacting with a computer, but a human is responding to output rather than the system. Usually done early in design to understand user expectation. Just like in a FB page, kapag nag-message si user dun sa FB page, merong agad na magre-reply, which is we think na computer yon. But actually, it's a human na talagang ginagawa or isiniset yung mga isinasagot sa atin ni computer. Like, for example, yung page is for online business, for a food. The common message or questions na nare-receive ni computer is the questions of how much is this available, and so on. And yung mga question na isinasagot ni computer sa atin is isiniset lang ni responder, which is responder is a human. Yung mga siniset ni responder na answers is tugma dun sa mga questions ni user. Para kapag nagtanong si user sa computer, is kaya na ni computer sagutin yung question ni user kahit na hindi nakatutok sa computer si responder. So next is, what is wrong with this approach? Ang mali dito is nakatutok pa rin si responder sa computer. Gaya nga ng sabi ko, yes, si responder or si human ang sumasagot sa atin or kay user. But usually, yung mga sagot niya is nakaset na nga. Example nga is sa questions kanina. Isiniset na ni responder yung mga answers for user's questions. So, dapat sa figure is si computer na lang ang kaharap ni user. Hindi na dapat kasama si human. Next is high fidelity prototyping. Uses materials that you would expect to be in a final product. Prototype looks more like the final system than a low fidelity version. High fidelity prototypes can be developed by integrating existing hardware and software components. Danger that users think they have a complete system. So yun nga, they usually use the materials na alam na nila or ina-expect na nila na yun na yung final product. For example is a prototype of a software system na na-develop sa Python or sa kahit anong executable language is a higher fidelity than a paper-based mock-up. Another example is a molded piece of plastic with a dummy keyboard would be a higher fidelity prototype of the Palm Pilot than a lump of wood. Next is compromises in prototyping. Prototyping involves compromises. For software-based prototyping, maybe there are slow response, sketchy icons, limited functionality. In the wild, prototypes operational but not necessarily robust. Two common types of compromise. First is horizontal, which provides a wide range of functions but with little details. Next is vertical, which is kabaligtaran naman siya ni horizontal. It provides a lot of details for only a few functions. Next is compromises in prototypes must not be ignored. Product needs engineering. So, in 2008, Yon Kyung Lee suggests an anatomy of prototyping that structures the different aspects of a prototype and what it aims to achieve. The kind of questions that any prototypes can answer is limited lang, and yung prototype must be built with an issue in mind. Lastly is conceptual design. A conceptual model is an outline of what people can do with a product and what concepts are needed to understand and interact with it. Understand problem space and current requirements. Empathize with users. Creativity and brainstorming techniques. Movie board may capture this desired feel. Considered alternative scenario and prototyping helps. So in short, it is a scalable drawing that defines the basic parameter of a project or the product. Conceptual design or conceptual model, ito yung outline kung saan ginagamit ni user or ng mga tao para malaman kung anong pwedeng gawin or kung paano gagamitin yung product na natapos na. They are usually void of detail, dimension, and technical notes. So you can review and modify the design with ease. Some of example nito is e-health, customer self-service, 360 client view, robotics, and 3D printing. So that's all for my report. Thank you.
Good day, my name is Melissa Magbag. So, choosing an interface metaphor. Interface metaphor combine familiar knowledge with new knowledge in a way that will help the user understand the product. So basically, it's like how different components works using similar concept. So for example, you're about to withdraw money using your ATM cards. Sometimes you will go to their physical branch to withdraw your money. You fill out forms there and something like that. Same thing can be done sa online. When you're withdrawing a money, transferring to someone, you use the same analogy that you apply in the different kinds of scenario. So next, these are the 3 steps of choosing a good interface metaphor. So first, understand functionality. Parang ano lang to, it's what functionality you will provide to the user. And then, identify potential problem areas. So, pag alam mo na kung paano yung iba't ibang function ng products mo, is ma-identify mo na yung mga posibleng maging potential problem areas ng user towards your products. So, after mong malaman yon, is pwede mo nang i-generate yung metaphors niya. So, next, evaluate metaphors. How much structures it provide? How much is it relevant to the problem? It is easy to represent. Will the audience understand it? How extensible is it? So next, considering interaction and interface types. So, which interaction type? How the user invokes action. So, dito po is like, you tell something to do with the product. It's like giving commands, like instructing, conversing, manipulating, exploring, or responding. So, isang example dito is yung sa manipulating. It's parang, yung naglalaro ka ng games. Parang, ikaw yung nagko-control kung paano ka magpo-proceed sa laro. Like, isa-set up mo kung paano, ikaw yung mismong mag-aayos. Yun. So, next. So, basically, yung interaction type, it's like, how you give some access to the program to do something for you. So, do different interface types provide insight. So, pag alam mo na kung paano nag-i-interact kung paano yung nagiging interaction between the user and the product. So, susunod na rito yung interface types. So, first, shareable. As it intended to be used by a group of people. Tangible, are kind sensor-based interaction where blocks or other physical objects are moved around, and reality and so forth. So next, expanding the initial conceptual model. So what function will the product perform? What will the product do and what will the human do? So dito naman is parang ikaw yung magbibigay ng input and the product will do it accordingly. So, ang best example nito is si Alexa. Kilala naman natin siguro si Alexa. Yan. So, when you want to do something, kailangan isasabihin mo siya kay Alexa. Parang, pag may gusto kang ipagawa sa kanya, parang sasabihin mo lang sa kanya, tapos gagawin niya. For example, Alexa, turn off the lights. So, susunod si Alexa, papatay niya yung ilaw. So, kung anong sabihin mo sa kanya, siya naman gagawin niya. Pwede ka rin magtanong sa kanya kung, Alexa, what is the weather today? Yun, so, yun. Ayun, marami siyang bagay na nagagawa. Ganun. So, kailangan mo lang siya i-instruct. Tapos, gagawin niya na. Ayun. So, next, how are the function related to each other? Sequential or parallel? So, kailan ba natin pina-perform yung sequential or parallel? So, yung sequential is like, nagpi-fill out ka ng forms. So, minsan, lalo ngayon sa atin sa online school, kailangan muna nating mag-login para magkaroon tayo ng access dun sa files na pinapa-fill out sa atin. So, yung parallel naman is like, parang yung naglalaro ka at the same time, meron kang music. Yan. Parang sabay siya. Pwede siyang pagsabayin. So, next, categorization. For example, all action related to privacy on a smartphone. So, next, what information is needed? What data is needed to perform the task? Is what you have in the initial conceptual model. So, next, how is this data to be transformed by the system? Is how the data transformed by the use of the system in order to provide the initial expected output. So that's all. Thank you.
Good day everyone, my name is Aaron Fajardo from Cybersecurity 11. And my discussion is all about concrete design, generating prototypes, generating storyboards, generating card-based prototype, and explore the user's experience. Conceptual design and concrete design are closely related. The difference between them is rather a matter of changing emphasis. During design, conceptual issues will sometimes be highlighted, and at other times, concrete detail will be stressed. Producing a prototype inevitably means making some concrete decision, albeit tentatively. And since interaction design is iterative, some detailed issues will come up during conceptual design and vice versa. There are many aspects to the concrete design of interactive products: visual appearance such as color and graphics, icon design, button design, interface layout, choice of interaction devices, and so on. Chapter 7 introduces several interface types, together with their associated design considerations, guidelines, principles, and rules, which helps designers ensure that their products meet usability and user experience goals. This represents the kinds of decisions that are made during concrete design. Concrete design also deals with issues related to user characteristic and context. Accessibility refers to the extent to which a product is accessible to as many people as possible, while inclusiveness means fair, open, and equal to everyone. The inclusive design is to empower users in their everyday and working lives. A range of input and output modes is available for interaction design. Apart from standard keyboard, mouse, and touchscreen, there are also different pointing devices and keyboards, screen readers, refreshable braille, and eye tracking, among others. Regardless of which alternate input or output modalities are used, interactive interfaces must be flexible enough to work with these various devices. This is particularly important for users with disabilities who may be unable to use pointing devices or standard keyboards and may instead interact using a head or mouth stick, voice recognition, video with caption, audio transcript, and so on. Aspect of cultural design includes use of appropriate languages, colors, icons and image, navigations, and information architecture. These are all important for concrete design. However, tension between local cultures and HAI principles have been highlighted, together with the desire to reframe human-computer interaction. Local and indigenous perspective. These concerns not only impact concrete design but also wider issues such as what to design and how to design in order to be accepted by the target user group. Generating prototypes. This section illustrates how prototype may be used in design, and it demonstrates how prototypes may be generated from the output of the requirements activity. Producing a storyboard in a scenario and an index card-based prototype from a use case. Both of these are low-fidelity prototypes. Generating storyboards. A storyboard represents a sequence of actions or events that the user and the product go through to achieve a goal. A scenario is one story about how a product may be used to achieve that goal. A storyboard can be generated from a scenario by breaking the scenario into a series of steps that focus on interaction and creating one scene in the storyboard for each step. The purpose for doing this is twofold. First, to produce a storyboard that can be used to get feedback from users and colleagues, and second, to prompt the design team to consider the scenario and the products used in more detail. For example, consider the scenario for the travel organization developed in Chapter 11. This can be broken down into 6 main steps. 1. Will, Sky, and Imon gather around the organizer, but Claire at her mother's house. 2. Will tells the organizer their initial idea of a sailing trip in the Mediterranean. 3. The system's initial suggestion is consider a flotilla trip, but Sky and Imon aren't happy. 4. The travel organizer shows them some descriptions written by young people about flotilla trips. 5. Will confirms these recommendations and asks for details. 6. The travel organizer emails details of the different options. Notice that the first steps sets the context and later steps focus more on goal. Breaking the scenario into steps can be achieved in different ways. The purpose of working from the scenario is for the design team to think through the product and its use. And so the steps are not as important as the thinking that happens through the process. Also notice that some of these events are focused only on the travel organizer's interface, and some are concerned with the environment. For example, the first one talks about the family gathering around the organizer, while the 4th and 6th are focused on the travel organizer. Storyboards can focus on the screens or on the environment, or a mixture of both. Either way, sketching out the storyboard will prompt the design team to think about design issues. For example, the scenario says nothing about the kinds of input and output devices that the system might use. But the drawing the organizer forces the designer to think about these things. There is some information in the scenario about the environment within which the system will operate, but drawing the scene requires specifics about where the organizer will be located and how interaction will continue. When focusing on the screens, the designer is prompted to consider issues including what information needs to be available and what information needs to be output. This all helps the explore design decisions and alternatives, but it is also made more explicit because of the drawing act. Generating base prototypes. Card-based prototypes are commonly used to capture and explore elements of an interaction, such as dialogue exchange between the user and the product. The value of this kind of prototype lies in the fact that the interaction elements can be manipulated and move around in order to simulate interaction with the user or to explore the user's end-to-end experience. This may be done as part of the evaluation or in conversations within the design team. If the storyboard focuses on the screens, this can be translated almost directly into a card-based prototype and used in this way. Another way to produce a card-based prototype is to generate one from a use case output requirements activity. For example, consider the use cases for the visa requirements as aspect of a group travel organizer presented in section. The first, less detailed use case provides an overview of the interaction, while the second one is more detailed. This second use case can be translated into cards as follows. For each step in the use case, the travel organizer will need to have an interaction component to deal with it. For example, input via a button, menu option, or voice, and output via display or sound. By stepping through the use case, a card-based prototype can be developed that covers the required behavior and different design can be considered. For example, figure shows 6 dialogue elements of 6 separate cards. The set on the left has been written in friendlier language, while the set on the right is more official. This covers steps 1, 2, 3, 4, and 5. The alternative courses, for example, those dealing with error message, would also each have a card. And the tone and information contained in the error message could be evaluated with users. For example, step 7.1 might translate into a simple, no visa information is available, or a more helpful, I am not able to find visa information. For you to visit your chosen destination, please contact the destination country's embassy. The cards can be shown to potential users of the system or fellow designers to get informal feedback. In this case, we showed these cards to a colleague, and through discussion of the application and the cards, concluded that although the cards represent one interpretation of the use case, they focus too much on an interaction model that assumes a WIMP interface. Our discussion was informed by several things, including the storyboard and the scenario. One alternative would be to have a map of the world, and users can indicate their destination and nationality by choosing one of the countries on the map. Another might be based around national flags. These alternatives could be prototyped using cards and further feedback obtained. Cards can also be used to elaborate other aspects of the concrete design, such as icons and other interface elements. A set of card-based prototype that cover a scenario from beginning to end may be the basis of a more detailed prototype, such as an interface or screen sketch, or it may be used in conjunction with personas to explore the user's end-to-end experience. This latter purpose is also achieved by creating a visual presentation of the user's experience. These representations are variably called a design map, a customer journey map, designing the experience example wow. So the name of the experience is Flight to New York City. Description: Richard is a tall senior executive traveling as a part of work. So as we can see before, contact travel department, book tickets, check in at Paddington train station, receive tickets, Hatro Express train to airport, expedited security and passport checks for frequently flyers, and more. Use the experience icons. How can this be a positive experience? Make or break moments that we can do to make sure consumers come back time and time again. Where do we need data to help deliver the experience? As we can see, using this experience icon, we know if they're happy or not. This will help you to improve. An experience helps you to see the big picture of your customer's journey, to further understand their needs and pain points. It makes collaboration between designers, developers, and managers easier, effective, and focused. It facilitates desired outcomes by pinpointing and minimizing negative customers' experience. On design map, it's also the same, because we can see in this design map the weaknesses of the presentation of Megan delivers. We can see here what we need to improve of and focus.
Good afternoon, everyone. I am Shiela Mae Andoyo, the last reporter. Construction, physical computing, build and code prototypes using electronics. Physical computing is a building, designing, and creating interactive systems that uses different kinds of software and hardware to sense and respond to an external stimuli. Available include the Arduino. Arduino is an open source electronic platform based on easy-to-use hardware and software. Meaning to say, Arduino boards are able to read inputs light on a sensor, a finger on a button, or even a Twitter message, and turn it into an output. One is the LilyPad for fabrics. The LilyPad Arduino is a microcontroller board designed for wearable and e-textile, meaning to say it is a set of sewable electronic components for building fashionable clothing and other textiles. The LilyPad was co-developed by Leia Buchley. The next one is a SenseBoard. SenseBoard is a touchless input device for hand motion detection. This SenseBoard is an output device that detects hand movement without touching its surface. Meaning to say, the hardware of this device is composed of capacitive sensors. Next one was the BBC Microbit. BBC Microbit is one of the most recent physical computing systems. It consists of physical computing device that is used in conjunction with an IDE. Meaning to say, this device contains a number of built-in sensors and small displays so that it is possible to create simple physical computing systems without attaching any components or wires. The last one was the Maki. It is composed of printed circuit board with an Arduino microcontroller, alligator chips, and USB cable. It communicates with the computer to send key presses, mouse clicks, and mouse movement. This is the picture of Arduino board. And this one was the Maki toolkit. This last picture was an example picture of the BBC Microbit. The Software Development Kits. It is a programming tools and components to develop for a specific platforms. For example, is the iOS. An SDK includes an integrated development environment, documentation, devices, and sample programming code on how to illustrate to use the SDK component. Includes the IDE, documentation, drivers, sample code, and application programming interfaces or API. The SDK will include a set of application programming interfaces that allows control of the components without the developer needing to know the intricacies of how they work. It also makes the development much easier. And the example of this was Amazon's Alexa Skills Kit for voice-based services, the Apple's ARKit for augmented reality, the Microsoft's Kinect SDK for motion tracking.